This video we are going to talk about a HTTP request in Rust programming language. So how to make an HTTP request in a Rust programming language. That is what we are going to see. For that, you would know basic understanding on the Rust programming language, and some extent you would know the async programming in Rust. You might have seen my Python programming, how to make HTTP request in Python programming. So I'm trying to replicate the same, how to do it in the Rust programming language. So having said that, we need to create a project that you can do cargo new and Rust HTTP client exp1. That is the name of my project. I'm giving just a random name and dash dash bin. That will create a binary project. So that means we can call and execute uh, the binary created from this project. So once you have done that command, you will be getting a project structure, something similar to this. You will have an src folder and a target folder and cargo.log and cargo.toml. So the main file is cargo.toml. That is where we mention all our dependencies. So here I'm going to use request. That is the simple HTTP client. Let's see what is the in doc.rs request. Yeah, request create provides a convenient higher level HTTP client. So that is what we want, a library where all the lower level HTTP is coded, and we can simply use get request, post request and all. So, and we need to go to this src folder, and here we have the main.rs. First thing is, uh, since we have given like this, um, we don't need to use the specific modules. It is automatically taking. If you give tokio main, it is going and checking and getting the tokio main functionality from this module. Um, so having said that, so this is one of the type I have defined. I just give one, maybe I can keep it as my error, um, just to be explicit. Why I'm giving that is, I don't want to type like box dyn standard error. So when you're returning a dynamic error, we usually box it in Rust and put it in a Rust enum. So since Rust doesn't have a runtime, we need to use the external library. Here it's Tokio. We are using the Tokio runtime. So runtime is what the running environment for this program is getting executed. So we need to use an attribute macro, Tokio main, to specify the just below main function is the starting point of the execution for this runtime. So we need to start with async main, and the return type is result, and unit type, I think it's this unit type, and the error we have defined here. So as far as you have this setup, we can directly jump into our application logic, where we need to send a get request to our http bin.org. Here I am calling the headers endpoint. So since this is an asynchronous call, we need to wait on the response, otherwise it will just return a future. So we need to make sure we have a response back. For that we need to wait, and we have a question mark to propagate. If there is any error in this process, it should propagate that error to main my error. So yeah, if you don't want to propagate that, you can just do dot unwrap, but time being it's good to propagate the errors. And once you have the response, we can actually do a headers method. Yeah, headers method on this subject, response subject, that will print out the headers. And since this um, block of async function need to return something with result, we are returning an OK unit type to show the program, to return the program that we have done everything, and we are returning a unit type OK. OK enum variant with unit type. Yeah. So if you have this setup, you can very well call this program. We can call with cargo run. That should print the headers returned from http pin.org. The same thing you will get when you do http headers here. I hope this is the same thing we are getting. Let's see, date. This is actually different. Most content JSON. In default, it is coming as JSON user agent Mozilla 5.0. 139 connection alive. Connection. This is not what we are getting. It's not the endpoint, I believe. Was not sure why that we are getting different here. I think this is the response actually we are getting. Okay, leave that. And if you want to spawn another asynchronous function, we can do like this. Tokio, we can spawn a asynchronous block with another request. I'm doing the same get request on http.org.get and trying to print the contents. So here I'm getting the text, so all body will be text, and I can print that here. So since this is a spawn, it's basically Tokio is spawning a thread and trying to complete the task, and it will just schedule this task and won't wait for this. It will come to this point and start sending this request, and here we are awaiting, so it will wait for the blocking. So we'll wait for the response and print that headers. And I want to, if I run this, yeah, still you're not seeing the body. We haven't got the response back. So that is because we didn't wait for this asynchronous block. So we need to actually wait. So since we got a handle here, we can just wait on the handle. So it will wait for this asynchronous block to finish. So now if we save this and execute. It is taking a little time. Finish both the requests. Yeah, we got the response. And the first one is the body of this request, and the second one is this one. And since you are waiting on this, we got that response also. Even though we are waiting here, we got this one first. This got the output first, then only we are getting these headers. Yeah, it won't be same in the order what we are seeing here. Can be anything. So if I want to try, I want to definitely print this first, then uh, the best way would be, need to wait on that. How should I wait on here? Mm, Takeaway is, even though we are placing handle.await here, don't expect that this is going to get printed after this. So that's what um, async programming, the sequencing is little tricky. If you're writing a synchronous program and then it can try to sequence, then that will be difficult. We can spawn a lot of async functions and try to join all the handles so that we can make sure that all the asynchronous functions are getting executed. So the priority sequencing is, it's again tricky in asynchronous programming. Okay, thank you. That's all I want to cover in this video. We will see in the next one. Thank you.